Imagine a force 100 times greater than any bomb ever detonated on Earth. Now picture this unimaginable power unleashed on the surface of the moon. Our closest celestial neighbor, a silent sentinel in the night sky, would become the stage for a spectacle as awe-inspiring as it is terrifying. This is the scenario we're about to explore. A 100-megaton thermonuclear warhead, a weapon of unimaginable destructive potential, detonated on the lunar surface. In the vacuum of space, where sound cannot travel, this act of aggression would begin with a silent scream of energy. The moon, with its desolate beauty and airless expanse, would bear the full brunt of this cosmic tantrum. But the consequences wouldn't be confined to our celestial companion. The repercussions of this event would ripple through the fabric of space, carrying profound implications for humanity's relationship with the cosmos. At the heart of this hypothetical event lies the 100-megaton thermonuclear warhead, a device of intricate engineering designed for maximum destructive yield. In the moments following detonation, a chain reaction of unimaginable speed and power would be unleashed. Think of a tiny sun being born in an instant, unleashing a blinding flash of energy visible across millions of miles. This burst of radiation, traveling at the speed of light, would be the first sign of the catastrophe to reach Earth, a silent harbinger of the chaos unfolding on the lunar surface. The intense heat generated by the explosion, reaching millions of degrees Celsius, would instantly vaporize a large chunk of the lunar surface. This searing inferno, however, would be a silent affair. With no atmosphere to carry sound, the lunar landscape would be consumed in a silent, invisible firestorm. Unlike Earth, where the atmosphere acts as a medium for shock waves, the moon's lack of air would result in a unique phenomenon. The explosion, instead of generating a deafening roar, would produce a silent, expanding bubble of energy. Imagine dropping a pebble into a still pond. The ripples spread outward, disturbing the tranquility of the water's surface. Similarly, the energy released by the explosion would radiate outward in all directions, unhindered by the friction of air molecules. While there would be no sound, the moon itself would shudder under the force of the blast. Seismic waves, akin to those produced by a powerful earthquake, would ripple through the lunar interior, potentially altering its geological structure in unpredictable ways. Section 4, Scars in the lunar dust. The immediate aftermath of the explosion would leave a scar on the lunar landscape visible from Earth. A massive crater, miles wide and hundreds of feet deep, would mark the site where the weapon detonated, a permanent reminder of the destructive power unleashed. Debris from the explosion, consisting of vaporized rock and molten material, would be ejected into space at incredible speeds. Some of this debris might escape the moon's weak gravity, becoming a hazard to satellites and spacecraft in lunar orbit. The fine dust kicked up by the blast, no longer bound by an atmosphere, would spread out in a vast cloud, potentially creating a temporary, faint ring around the moon. This ethereal halo of destruction would serve as a stark reminder of the event that transpired. Section 5. Reflections in the Void. The detonation of a nuclear weapon on the moon, a chilling hypothetical scenario, forces us to confront the immense power we possess and the responsibility that comes with it. The moon, a silent observer to human history, would bear the scars of this act for millennia to come, but perhaps the most profound impact of such an event wouldn't be the physical damage inflicted upon a celestial body, but the psychological and philosophical implications it would have on humanity. It would serve as a stark reminder of our capacity for both creation and destruction, a duality inherent in our nature. Instead of directing our technological prowess towards acts of cosmic vandalism, we could choose to harness it for exploration and discovery. The same energy that could reduce a portion of the moon to a smoldering crater could power our cities, propel us to distant stars, and unlock the mysteries of the universe. The choice, ultimately, lies with us.